Okay, so I got it. So let me share the screen. Okay, so everyone can see the screen, eh? Can see the screen, eh? Okay.
Yes.
So good. So we go back to what we stopped last class. Okay. Okay. We done about the pulley. So we stopped at here, right? Yeah, here. So we just solved these questions today, and then we go ahead with another part. Okay. So let's proceed from here. Okay. How do you do this question? You tried this question before. Okay. So this is your pulley. So the acceleration of the system, as I said, this is an application of Newton's law, first law, second law, and third law. So pulley case, you want to analyze. You have to split them into two. Maybe you take this as one system and write the formula. Okay, what is same for both system will be the tension and the acceleration is the same. If this is going down, this must go up with the same acceleration. Acceleration must be the same. If this tension up, this also will have a tension upwards. The tension also the same. I told you earlier. Okay, now for the first system, can you find the equation first? What is the first system? What is the equation will be by using first law? By using second law. What equals to ma? For the first equation. So the force down is what force is acting? 24 G, 9.81 lah, 24 times 9.81. Okay. Acting down the weight, tension acting up. So weight greater or tension greater? Because here the other side is 10 kg and 24 kg. Definitely we know 24 kg going to go down. So therefore the weight is greater here. First one. So how you write? So 24, what? 9.81 minus the force up, which is tension, will equivalent to MA. Which M do you use? M use only 24. Okay, only 24. 24A. Okay. So this is the first equation. How many unknowns are there? How many unknowns? You have two unknowns. You don't know the tension, you don't know the acceleration. But the question asking for both, part A, part B asking for both. We make equations first. Okay. Second, can you get equation by using the second one? Okay, now use the second system. Get the equation. Second system. Get the equation.
T minus 10.
Okay, so of course tension is greater now. So T minus 10 times
9.
What?
Negative.
No need to put negative positive, just positive 9.81. Negative positive only for thing, yeah?
Yes.
Is equals to what? Is equals to M. M is 10. 10A, Okay, this is the second equation. Gravity in dynamic, only in kinematic you consider positive, negative for gravity. For dynamic, just positive. Okay, so you got two equations. So if your maths is good, this is a simultaneous equation. You can work out for the T and the A. Okay, but I'm interested more to equation. Okay, now can you form the third equation? The third equation is combining both together. What the formula you'll get? Third equation. Anyone? Third equation combining all of them together. That means the force pulling it down is weight of the 24. The force which is opposing the movement is weight of the 10. We pack them together. That means the tension won't involve. Okay, just the force outward. So what is the force pulling it down? 24 9.81 is the one force pulling it down.
Yes.
Minus what force opposing? What force opposing it? The 10, the weight of the 10. The 10, 9.81 is equals to what? Equals to MA. Which M do you use? MA. Which M do you use? Because you are considering the entire system, so we consider the entire mass. Consider the entire mass because the net force here, the weight of the 24 minus the weight of the 10, actually pulling the entire mass. So it's going to be how much? 34. Okay, 24 plus 10, 34. This is the third equation. Okay, so those who can form these three equations out of this system, okay, you are in a correct track. Okay. Okay. So now get me the answer for the first one. What is the acceleration of the system? So which formula you can use? Do you want to use the first and second, or do you want to use the third? Third is the easiest for this case. Why? Third equation, the only unknown is acceleration. Okay. So if you take the entire system, the t won't appear. So if the question never asks for the t, you don't allow the t to appear. How do you allow the t to not appear? You take the entire system. Okay, you take the entire system, so the t not appear. You see the third equation, t doesn't appear. Okay, so I think for the part A, the third equation. So anyone got the answer? What is the A? A, 24 weight of the 24 kilogram minus weight of the 10 kilogram divided by 34. You get acceleration. So anyone got the answer?
Yeah.
Can you tell me 3 SF? Sorry, made a mistake. Okay, anyone?
4.04.
2.04. 2.04.
4.04.
4.04. Sorry, I cannot go to the chat. So 4.04. Everyone got 4.04? Let me see. I can go to the chat or not. You can chat, right?
Yes. Only owners can send messages to this channel.
Oh, okay. Made a mistake. Okay. Yeah. Sorry. So you get what? A? Working. So A is what? A is
4.04.
4.04. Okay, so all of you got 4.04 meter per second square. Okay, tension. Now you can get the tension. Tension use either the first one or the second one separately. Okay, if you use the first one, let me write back. So if you use the first one, 24 what? 24 9.81 minus tension will give you 24A. Just using the first system. So A you already know is 4.05. So you can work out the tension. Anyone got the tension?
It's 4.04 because 4.039.
Oh, 4.04. Okay, everyone got the same answer. Anyone got a different answer? 4.04 Newton. Okay. So the important here is the three equation I draw you just now earlier. Okay, you must know how to draw the three equations. Okay. Okay. So the first one. We go to the next one. Okay. So use the same method. This question. Use the first law, second law, third law. Write three equations. Separate them into separate system first. Separate them. This is the first system. Okay, this one going to be the first system, and this is going to be the second system. The second system. Okay, then we combine all together. So what the question one? Question 1 for the magnitude of the force friction. Find the tension of the string. You want the tension. 4 kilogram is horizontally dragging, but the surface here got friction. How much is the friction? The friction is found to be 11.8 Newton. Find the tension of the string. Okay, first, you need to identify all the forces first. Okay, let's go for the first system. For the first system, what are the forces acting on 4 kg? The tension is acting on the right or to the left? To the right or left?
Left.
The tension is?
Oh no, right.
Assuming like you are the 4 kg. The tension, the string is pulling you to the right. So the tension is to the right. Okay. Then friction is acting, weight acting down, of course, for 4 times 9.81. Okay. Then what force opposing it? The friction. Okay. The friction is found to be how much? 11.8. Okay, so for the first equation, the first equation is going to be what? Just focusing to the 4 kg. What equals to MA? MA means 4A. 4A, because we are just focusing to 4A. Tension greater or the 11.8 greater? Tension greater or 11.8 greater? Tension is greater, right? Because the 2 kg pulling it down, so the 4 kg is actually accelerating to the right. So the tension is greater. So how is the equation going to be? Tension minus 11.8. Yes, this is the first equation. Tension minus 11.8 is 4A. Okay, this is the first equation. Can you get the second equation? This is the second system. Tell me all the forces acting. Force acting down is what? 2 times 9.81. Okay. Tension acting upwards. Okay, tension acting upwards. Because it accelerates down. So what happened? So force down is greater. Force down is greater. So how's the equation going to be? Second one? 2 times 9.81 what? Minus tension equals to, which mass to be used? Because only second system we are using what? So only 2A. So it's 2A, second formula. And the third formula, anyone? Third formula, combining all three of them, what equation are you going to get? That one, combining all of them, combining the entire thing as one system. Okay, the combining entire thing is one system. What is the force pulling it down? The 2 times 9.81. What is the force opposing it? Friction. Okay, the intermediate force, no need to involve. So what equals to MA for the third one? Third one, entire system, M going to be the entire mass. So it's going to be 6A. 6A. So what is the force pulling it down?
9.8
times 9.81. What force opposing? The friction is opposing it. So 11.8. Okay, so these are the 3 equations you need to use to solve it. Okay, so how you're going to do is up to you. Okay, maths. Because for the sake of finding the tension, you have to, tension only involved in the first 2 equations, 1 and 2. Okay, but to sake of finding the tension, you need to know the acceleration first. So if I were you, I'll go for the third equation. I go for the third equation. Find acceleration first. Can you find the acceleration, anyone? What's the acceleration you got? Here's the third equation.
1.30.
So you got 1.30. All of you got 1.30. Okay. Any mistake? Tell me. If you got any contradict answer. So 2.98 minus 11.8 divided by 6. You get the acceleration. Okay. So 1.30. Okay. So 1.30. Now what do you do? Sub this value into which equation? Either 1 or 2 lah. So let's say we go for the 1. the one. So find the tension. Tension is what? Is for A. A is what? 1.3 plus 11.8. 11.8. Yeah, correct. 11.8. You got the tension. Anyone got tension?
17.
17 point.
Wait, is it 17? Yes, 17 newtons. It's 0.0. It's 0.0.
10.0 Newton. Okay. So this is how you work out. Okay, yeah, this is how you analyze the system. Important is not the final calculation. Important is the how do you get these three formulas. Sometimes in the Cambridge, they do not interested to the final answer, tension or acceleration. What they will ask you to do is write three formulas based on this system by using Newton's law. So they just ask you to write these three formulas. Okay. They're not really interested to the calculation, but sometimes they do ask to the tension and acceleration too. Okay. Okay. Any questions about this? So in this pulley, you can make three equations. Split them, get 2. Combine them, you get 1. Split them, the tension will be in the equation. Combine them, the tension won't involve. Okay. So any question? If you don't have question, then we go to the next one. Okay, so all of you get 1.3 meter per second squared, your acceleration, and tension is 17 Newton. Okay. So now next, go to the next one. Okay, this one. Okay, so how do you do this? This is the inclined surface. Can you write three formulas on this system? Question is still the same. Find the acceleration of the car and the tension of the cable. So anyone got the answer for the, just how do you do this?
Find the resultant force. Wait, the.
Okay, yeah.
Yes.
So first get all the forces acting on the car first. The car. What force acting up? Tension. What force? Tension. What is the force acting down? Anyone?
Gravity.
The gravity force acting straight down, right?
Yeah. So.
But you resolve to the side, it becomes mg sin theta or mg cos theta.
It's
Anything cos here. Inclined surface. If this is 30 degrees here, if I draw a line, here will be 30 degrees. Okay, here will be 30 degrees. Why here will be 30 degrees? You see this line and this line. I draw another line. Assume these two lines is parallel. This two line is parallel. This angle is how much? 90 degrees. Okay. So you remember last time in your early studies, the internal angle of two parallel lines should be how much? 180, right?
Yes. Yes.
If you have a two parallel line, and you got it like this, the internal angle is 180, right? So here already 90. That means the 30 plus this theta, this angle will be how much? 30 plus theta will be also 90, right?
Yes.
So here itself also is 90. Here also 90. Also 90. So theta plus theta here should be 30 degrees. Theta plus 30 here, 30 theta here also 30. Should be 30 because here also 90. Okay, here also 90. Like, okay. So here 30 degrees. So mg acting down, here 30 degrees. Mg you move to this side. This component will be mg cos theta or sin theta. You close the angle or open the angle? So 30 degrees. When you move the mg here, you open the 30 or close the 30? Like you are open the 30, you know. Okay, when you move this mg to here, so you must use mg open what I told you. When you open the angle, you must use sine. Okay, sine 30. So open the angle, you use sine 30. So what is the force acting down? Mg sine 30. What is the force acting up? Tension. Okay. So this is the car forces. Okay. Finally, the car going up or go down because weight pulling it down. You assume because the cable connected 100 kg on the inclined plane stretch over pulley. So the car is accelerating up. We assume it's accelerating up. So this is the first system. By using the first system, can you get the formula first? First one, what is the formula? What equals to MA?
Equals to MA.
Tension greater or the mg sin theta 30 greater?
Tension.
So tension minus force down, which is mg sin 30. M is how much? 1000. 1000 what? G, put 9.81. Sin 30 equals to what? MA. What MS use?
1000.
1000 A. So this is the first equation. Okay, now get me the second one. Now second system here. Can you write what are the force acting on this system? The force up is tension. Tension is same cable. Force down is mg, but in this case it's 11 ton. 11 ton means 11,000 lah. So it's 11,000 the mass multiplied by the gravity. So it gives you the force down. So it accelerates downwards. It accelerates downwards. Then what's the equation? Second equation going to be? The second equation. What equals to MA? What equals to 11,000 A? Sorry, 11,000 A. So force down greater than the tension because pulling down. So 11,000 what? G minus
T equals 11,000 A.
Yeah, this is the second equation. Okay. Because the answer A, they want just acceleration. I think it makes sense for us to take the entire system. If you take entire system, how's the equation going to look like? If you take entire system, how the equation going to look like? So let's go and do the entire system. Entire system is we pack them together. We pack them entires together. So force down is what? The 11,000 G. The force pulling it down. The force opposing is what? Which force is opposing? The mg sin 30 is opposing. So what's the third equation? Third equation, let me do here. So third equation, I do here, the third equation. The third equation will be what? What equals to MA? What is M going to be? M is the entire mass. Yes, 1,000, 1,200. This is 11,000. This is 12,000, right, altogether?
12,000, yes.
Yeah, so the mass is 12,000. The mass is 12,000 A. And 3T is what? Yeah, the force opposing is mg sin theta. The force pulling it down is 11,000 G. So force pulling it down is 11,000 G, 11,000 G gravity minus the force opposing is mg sin 30. Which M? The car. 1,000 G, sorry, sin 30. Sin 30. Okay, so you have three equations. 1, 2, and the third one. So now tell me, Which one do you use to find acceleration? Which equation is suitable?
Third one.
I think the third one. The third one is more suitable. Why third one suitable? Because only one unknown, only acceleration is there. Okay, calculate for me. Use the third equation. Calculate for me. How much is the acceleration?
8.58. 8.58.
8.58. Everyone get 8.58? Okay. So by using the third equation, you get the acceleration. Now get the tension. How do you get the tension? I think now you can use the first one or the second one. Let's use the first one. Get the tension. T minus 1000 G sine 30 equals to 1000 A. A, you know, 8.58. So what's the tension you got? 3 SF. 1000 times 8.58 plus 1000 G sine 30. Okay, the others, please help me to speed up the process. Okay. Ken? Anyone?
13,485.
So 13,500. We go for 3SF. Okay. So believe everyone got the same answer. If any of you got a different answer, we can check. Okay. So I need input from the others. Sorry, I think I mistakenly shut down the sharing. In the next class, maybe I can connect it back. Okay. Okay, this time I think I need your voice. Okay, I hope you can understand the system. Okay, every pulley system you can get 3 equations. Split them, you get 2. Join up them, one single system, you get 1. The third equation is very useful because tension won't involve, only acceleration will involve. So you can find the acceleration plus 1. Then you have to split them into 2 to find the tension. Okay. Any question from here?
No.
Okay, so let's proceed. Okay, now the most complex one. Okay, so how do you do this? Okay, neglecting friction at all surface mass pulley determine the acceleration of the block. Okay, here they want just the acceleration of the block. They just want the acceleration of the block. So what do you think? Because they want only acceleration, do you need to split them?
No.
Wait. You need to split them?
Just combine.
Just combine, because we don't want the tension to involve. So we don't need to split them. So we just combine them as one system. Okay, now we got a big problem. Is it 1000 kg going to slide down, or the 50 kg going to slide down? How to know? Is the force here bigger, or the force pulling it down here bigger?
You need to calculate.
You need to calculate. So calculate this force down here. What is the force pulling it down here? 100 times 9.81. What? Sine 30. What do you get? Anyone? What is the force you get here? 109 times 9.81 sine 30.
491.
491. Okay, 491 Newton. Okay, good. What is the force pulling it down here? 50, yeah, 9.81. You know, how much? Sine 60. Okay, what is the force acting down here? Is it bigger than 491? 50 times 9.81 sine 60.
425.
425. Good. 425 Newton. Okay, so we have to know which force is bigger. So it's found that 100 Newton force is bigger, 100 kilogram. So acceleration is of course down here, and you're accelerating up. So now we can make the third equation, I'll combine them. So 491 minus what? 425 force opposing. It should be equals to MA. Entire system mass, so which is how much? 150 A. Okay, we'll give you the answer. So the A equals to final answer. Meter per second square. Anyone? 491 minus 425 over 150. It's your acceleration. So we take the entire system.
0.44.
0.44. Okay, 0.443 SF. 440 is it? 0.440.
Yes.
Okay, 0.440. Okay, this is how you analyze by using Newton's law. Okay, so all the pulley you have to know. Okay. Okay, so let's move forward. Okay. So now another one question. This is lift. Same system. Acceleration. Find the force that lift exert on the man. Okay, 1,800 kilogram lift. You have a lift. The lift is 1,800 kilogram. It has 1,800 kilogram. And carrying a person, there is a person inside. Weight is 80 kilogram. 80 kilogram. Okay. And accelerating upwards. So it accelerates upwards. A is upwards. So the tension in the cable is 20,000 Newton. The cable up there has the tension 20,000 Newton. Okay. So this is your diagram. So what do you want? Find the acceleration. Find the acceleration. How much is the acceleration? So what are the force acting downwards?
Force
Acting downwards. The entire weight of the system, right?
Yes.
So that means how much? 1,880 times what? 9.81 is the force acting down, right? The entire weight, the entire weight. Okay, we are taking the entire system as one single system. The force acting up is the tension. The force pulling it down is 1,880 times 9.81. Can you find the acceleration now? What is the acceleration? By considering the entire system, the force up minus the force down should be MA. So what equals to MA? M, we take the entire system because MA, force up minus force down, right? Because it accelerates up. So force up is 20,000 Newton. Force down is what? 1,880 times 9.81. Yes, yes. This the equation must come to your mind. So you can get the acceleration. Anyone got the acceleration? 3SF.
$0.828.
Good, thanks. 0.828. 828. Okay, hope everyone got the same answer. So this is the acceleration of the lift going up. Okay, 0.828 meter per second square. Okay, so we're able to find the acceleration by taking the entire system. Force up minus force down. Okay, now it's going to be tricky for the part B. Okay, find the force that the lift exert on the man. Okay, what the force they're asking? What is the force exerted by the lift on the man? They're asking for, let's say you are standing here, imagine yourself, you are in the lift. What are the force acting on you? The weight pulling you down, just focus to that person, just focusing to that person, just here, the person, for the person. What is the force pulling it down? his weight. Only his weight. How much? 80 times 9.81. Pulling it down. What force acting up? The normal reaction. We call it what? Normal force, normal reaction. This part B question actually asking for the normal reaction. Part B is actually asking for the normal reaction. Correct? You see, the force that lift exert on the man is the normal reaction. The reaction by the floor. Because the person pressing the floor gives the normal reaction. So those who realize they're looking for normal reaction is good. We are looking for normal reaction. Okay. So which system do you consider now? You pack the system of the person alone, just the person alone. Okay. If you take the person alone, you can find normal reaction. Okay. The person is standing inside the lift. The force of acting on the person is normal force acting up, and the weight acting down, the mg is acting down, the atg. But the person is found to be accelerating where? Upwards. A. Can you make an equation now? What equals to ma for the person? Normal force bigger or atg bigger? Of course, it's normal force bigger because it accelerates upward. So, normal force minus at gravity 9.81. I put g should be equals to ma. Which mass do you be used? Mass of the person alone now, because we packed the person alone, so it's only mass of the person. So 80 A. Okay, sorry, yeah, 80 A. This is the equation you use for the second one. Okay, those before I explain, but you got this equation and you realize you're looking for normal force. Good, you're looking for normal force. So how many unknown here? We have 2 unknown, but A we already know. A is 0.828, so you can find normal force. So anyone can give the normal force to me? How much? How many Newton? 3 significant figure.
$851.
851. 800. Yeah, 851 Newton. Okay, makes sense. Yeah. Okay, so this is the case of lift. Okay, Newton's law. First law, especially the second law applies. Second law basically applies. Yeah. Okay, so in the lift, so you have to check if you want the acceleration, you take the entire system. Okay, whatever force acting up for the lift minus whatever force acting down, the total weight of the lift and the person together is the force acting down. You can get A acceleration. A. Okay, but if you want the normal force in the person, you just only consider the normal force. What do you call the system of the person alone? Okay, like I draw here the normal force and the weight of the person acting down. You can find the normal force. Okay, so the normal force and the tension is not the same. Okay, if you consider the weight of the lift. Any questions from here? The lift. Okay, so if the lift accelerate up, force up minus force down. Okay, if the lift is if the lift is accelerate down, then what do you have to do? If the lift is accelerate down, F1 down, F2 down. So then which force is greater? You must write F1 minus F2 equals to MA. Okay, that's my style of doing that. If accelerate up, force up minus force down. It accelerate down, force down minus force up. Okay, let's say a question asks, a lift is going down and the acceleration, the deceleration is -2. It decelerate. Okay, so A is -2 lah. Downwards, A is -2. So what do you do? So still you stick with what? Because the acceleration is downwards, although it's decelerate, but A is downwards. A is downwards. Always go F1 minus F2. F1 minus F2 is equals to MA, but A you put as what? -2. A put as -2. Clear, eh? So accelerate down, whether it's accelerating or decelerating, but the A is downwards, force down minus force up. But if it's decelerate, just A put as -2. This A make it positive or negative. Okay, hope we clear here. I believe lift you've done early studies. Okay, this all are Newton's law. Okay, this all are Newton's law. Any questions? So hope can. Okay, let's proceed. Okay, so these are the Newton's law questions. Okay. Okay. So let me go some question first for you to do first. I go back to the past year question. Okay. Okay. So the question I want you to do is okay, this one. This is question 15. This is what year is this? This is sorry, November 3. November 3, question 15. What is the answer? Okay, which quantity must be in the same direction? Anyone?
F and A?
Yes, good. F and A must be the same direction. Okay. Force and acceleration always the same direction. Can the velocity and force always the same direction? Is it velocity and force same direction?
Not necessarily.
Not necessarily. One example for that, your projectile movement.
Yeah, gravity is down, but the thing is going up.
Yeah, the gravity is always acting down, but the velocity is always changing direction. So velocity and what do you call acceleration is always, sorry, force and acceleration always same direction, but velocity not necessary. Okay. Okay. Another one thing you need to include here is the changes in momentum. The changes in momentum, the direction of changes in momentum, also same direction as the force and acceleration. Okay, please include here. Three things never be opposite direction. The three things always directed the same direction. The force, acceleration, and the changes in momentum. The direction of changes in momentum. Okay, they are same direction. Okay, it takes time. Okay, that means let's say you have a car here. Okay, you apply a force to the right. The force will be to the right. The acceleration will be to the right. The changes in momentum means what? Your mv minus mu. mv minus mu also will be to the right. Okay, three of them right. Okay. Okay. November 4, question 10. A constant mass undergoes uniform acceleration. Uniform means same acceleration. Which of the following is a correct statement about the resultant force acting on the mass? Yes.
B.
So which of the following? So B, it is constant but not zero. Yes, good. So the resultant force is constant but not zero. So if the resultant force is constant, the acceleration is going to be constant. Uniform means constant one. Okay, so this is the Newton's law. Okay, the remaining questions we can discuss later. Okay. Okay, so I go back to the slide. Okay, let's proceed further. Okay. So our next lesson is about momentum. Okay. So just another 30 to 40 minutes. We're going to do this. Okay, principle of conservation of momentum. Okay, you learn this, that what principle of conservation of momentum say? For a closed system, the total momentum of the system must be what? Conserved. Must be conserved. Cannot be lost, cannot be created. Momentum is always the same for a closed system. Okay. So the principle of conservation of momentum rises based on Newton's third law. Like for example, in this diagram, you see in this diagram here, the person pushes the second board while giving a 46 Newton of force. So of course, the first board also will experience force to the left with 46 Newton. It's action direction path. The principle of conservation of momentum rises from this Newton's third law. Okay. So like last time, the formula. If you have two body, M1 moving here with U1, and second body, M2 moving to the right, U2, and after collide, if this after collision, M1, let's say, moving to the right, V1, and M2 also, let's say, after collide, moving to the right, V2. So based on conservation of momentum, what is the formula you get? Total momentum before must be same as total momentum after. So M1 U plus M2 must be equals to what? M1 V1 plus M2 V2, right?
Yes.
So total momentum before and after must be same. That is principle of conservation of momentum. For this momentum to be conserved, the system must be a closed system. Closed system means what? If you take this as a closed system, you should not have any other force from outside interact with that system. No other force acting from outside to interact with this system. Then we say it as a closed system. Okay. So in a closed system, this momentum is applied. Principle of conservation of momentum. Momentum is vector or scalar? Momentum vector or scalar? Momentum is a vector quantity. So it has a direction. Okay. If the U2 here, instead moving to the right, if I say the U2 is moving to the left, U2 is moving to the left, how the equation going to change? The U2 is going to be negative. Therefore, this equation, instead of plus, it's going to be negative. Okay, it's negative. So anything move to the left, the momentum is negative. Okay. If V1 is to the left, let's say V1 also to the left, V1 is to the left, then now this equation going to be, the M1 V1 going to be negative. Okay, it's going to be negative. If it's anything move to the left, that momentum is negative. But now the question is, how they got this formula? How they got this momentum formula? By Newton's third law. The 46 I show you in the diagram. Okay, so next slide going to explain that how they got this equation. Okay, so no external force should act. No external force should act. Okay. So derived equation from the Newton's third law. Okay, so as I said, so you see the first diagram, F1 must be same as negative F2, Newton's third law. F1 is to the right means F2 is to the left, and is negative. Why negative? Because direction is opposite. Okay, so F1 is M1 V1 minus M2 U2. Sorry, M1 V1 minus M1 VU1 over T, because F1 is rate of changes of the first body. Okay. So second body is M2 V2 minus M2 U2 negative. Newton's second law. This is based on Newton's second law. Okay. So then the time of collision is the same for both of them. Okay. So you get like this. Time can be cancelled because time of collision is same for both body. Then you rearrange, you get the momentum formula. This is the one I wrote earlier. Okay. So how they got these two equations? From the Newton's third law and the Newton's second law. Okay. When both body collide, the time of collision same can be cancelled. So you rearrange, you get this formula. So this tells you what? The total momentum before collision is the same as total momentum after collision. Okay. So this is called principle of conservation of linear momentum. So the total momentum before collision is equals to total momentum after collision for a closed system. Okay. So how it rises? From Newton's third law and the Newton's second law. In exam, I think one past year they asked, try to form this equation, prove this equation. How they get this m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. So you have to derive from Newton's third law. You have to say f1 equals negative f2. These derivations you have to show. It's like a 2 marks question. Prove that. How do you get conservation of momentum? Okay, so Newton's third law and second law applies. Okay. So any questions from here? No, Okay. So of course, before and after, the collision differ from happens after. Okay. Before and after, of course, energy is conserved. A lot of things conserved. Energy, total energy is conserved. Of course, momentum is conserved. Conserved during collision. Okay. For a colliding system, it must be a closed system. So when these two collide, we neglect the force attracted by the sun. We are by assuming there is no other external force from outside. We assume this as a closed system. The force from the sun, we say it like a very neglected. Then we can use momentum is conserved. Okay. Of course, the time all are conserved. Okay. So now we are into collisions. How many types of collisions you learn? Okay. 2 types of collision, right? Elastic collision, inelastic collision. Okay. So first, this is elastic collision. How do you know elastic collision? So when you drop a ball, the ball hit the ground and bounce back at the same height is elastic collision. Elastic collision means what's conserved? What's conserved? Elastic collision means the kinetic energy must be conserved. Okay. So elastic collision means EK is conserved. That's your answer. Elastic collision means kinetic energies of the system is conserved. Okay. Kinetic energy is conserved. That means, let's say first body M1 and second body M2. Okay. When first body go and collide with the M2. Okay. After collision, first body and the second body move forward with a different kinetic energy. But if it's an elastic collision, the total kinetic energy before and after must be same. The EK must be same for both of them. Okay. If it's a elastic collision. Okay. Inelastic collision, of course, collide to the surface, bounces up, never rise to the same height. That means lose some kinetic energy already. Okay. The kinetic energy is lost. So inelastic collision means the total kinetic energy is not conserved. Okay, so it's inelastic collision. If collide, the ball is never rises up, stick to the floor, and this is called completely inelastic collision. Completely inelastic. Entire kinetic energy is lost. Not say lost. Is stick together. This is M1. Your ground is like the M2. Like M1 and M2. Okay, M2 moving forward with a different velocity U1 and U2. But after collide, what happened? The M1 and M2 stick together. M1 and M2 stick together, move with the same uniform velocity, and this is called completely inelastic collision. They stick together. Okay. Any body after collide stick together means they are completely inelastic collision. Okay. Okay. So this is a glider on an air track. We can, when we get into the lab later, maybe we can try this experiment. This glider, this track is connected to what do you call air pump. So the air will flow into this track, come out from these small holes. Okay, come out from these small holes. What happened? This small track can float, like it can float. So you can create a frictionless surface. So when you just slide it, it's going to float and move forward. So we create a frictionless surface. So here M1 is you move with the U1, M2 is in stationary. When M1 go and collide, what happened? M1 come to rest, M2 is move forward with V2. And this is called perfectly elastic collision. This one condition, M1 same as M2. Okay. The two plug, let's say, as the same as the first one go and collide with U1. Okay. After collide, the first one will come completely in rest. The second one will move forward with the same velocity as U1. Okay. Both kinetic of the total momentum before and after collision are conserved. So when the first one comes exactly in rest, second one move forward with this velocity. In this case, the V2 is same as U1. This only happens when the M1 is same as M2. Like a snooker ball, the playing pool, or the two balls have the same mass, M1 and M2. Okay, you strike the first one with the U1. When it collides with the stationary ball, the second ball is stationary. If the collision is elastic, let's say the collision is perfectly elastic, and the mass of M1 and M2 same, what we expected is the first ball M1 must come to rest, and the second ball M2 must move forward with the same velocity as the U1. Then it's a perfectly elastic collision. Okay, perfectly elastic collision. One special case. One special case. Okay, but in your real life, I think you go and play pool, and you hit the first ball, when it collide with the second one, the first ball still will start to move a little. They'll move forward a little. That means it's not perfectly elastic collision. Okay, tell me daily life, all the collision you are experiencing, the car collide with another car. Okay, is an elastic collision or inelastic collision?
Inelastic.
Inelastic. All are inelastic collision. Okay, I think 99.9999% is all are inelastic collisions. Okay, why? Kinetic energy not conserved. Any type of collision we observe on a daily basis, all are kinetic energy not conserved. When a car collides with another car, what happened? Some kinetic energy is lost. Okay, so what happened to the kinetic energy is lost? It tend to become heat and sound. Okay, if a collision is a elastic collision, means which rarely happens. If it's an elastic collision, you can't even listen the sound when it collides. No sound, no heat generated. Then it could be elastic collision. Okay, but scientists predicted that there is one type of collision. One collision is found to be elastic, predicted elastic collision. Anyone? There is one collision in the nature, in this world. They found one collision. They said it should be elastic collision. What type of collision? Yeah, something's colliding. They say it should be elastic collision. Which one? Is it a car colliding with car? Definitely, there is a sound created, so it's inelastic. There is one movement. Something is colliding with something. They say it should be an elastic collision. Which collision? Anyone? What? The air particles.
Okay. Oh.
The air particles. The air particles are colliding with each other. Billions of collisions happens. Okay, in a second, trillions. So the collision they say is it should be elastic collision. Why? Why they say it's elastic collision? You see here, the air particle Our universe formed 13.7 billion years. Okay, our Earth is like a few billion years back. So that we already have atmosphere. The air particles just keep on colliding for a few billion years, but they never come to rest. That means they are just keep on colliding. We never see the air become standstill. If they stand still, then we can say it loses kinetic energy, but it never loses kinetic energy. It keep on moving for after so much of billion years. So they say it should be an elastic collision. So we say the kinetic energy is conserved in a collision of the air particles. That's the only theoretical example for elastic collision, but not proven. But looks like it's elastic collision. Okay, so perfectly elastic collision is never happens, very rare happens. Okay, only happens for air particles. Okay, whenever collision got sound or heat, it's an inelastic collision. Okay, so yes, from rest, two skaters push against each other. The ice pushes one 50 kilogram, another one 80 kilogram. The woman moves away with a speed of 2.5. Find the final velocity of the man. Okay, what is the final velocity of the man should be? So we use conservation of momentum. Okay, so m1, the standard formula, m1 u1 plus m2 u2 must be equal to the final one, m1 v1 plus m2 v2. Okay, so before collision, what is the total momentum? Because they are in rest, both of them in rest, so the total momentum is 0, right? They never move because u1 u2 is 0, they are in rest. When they collide, when they push each other, the v1 is to the left, v2 let's say to the right, so the 2.5 is v2, we take it as v2, so you put it into the formula. So m1 is what? M1 is mass of the guy, so 88 m1 is 88. v1 we are looking for, plus m2 is what? M2 is the person, the woman, which is 54, and v2 is found to be how much? 2.5. So you put 2.5, positive 2.5, so you can get the v1. Okay, you can get the v1. So you have to use the momentum formula. m1 u1 plus m2 u2 is always same as m1 v1 plus m2 v2. Total momentum before collision is equals to after collision. Okay. So yeah, the working, the momentum, initial final. So this is what we did: 0 before collision, m1 v1 plus m2 v2. So v2 is like this. So you get the final answer. It's negative 1.5. v2 you get negative 1.5. Negative tells that is moving to the left.
Yes.
Okay, solution. Okay. So yeah, this is about momentum. Okay. Some questions first. Go back to the question. Okay, understanding the momentum. Okay, the first question. What's the answer? Juno 2, 9. Okay. So anyone got the answer? Okay, class. The next class, I tried to on the sharing thing. I think I mistakenly shut down. I have to go back because the Teams is a little different than the Zoom. Zoom, I have the toggles at the bottom. I can on it, but this one I have to go back. The next round, I think I let you share. Okay, so So this is two similar mass, like same mass, but traveling in opposite direction, both also the same velocity, same speed. Velocity different because different direction, moving each other. The sphere has an elastic collision. Be careful whenever collision question involved. Check is it elastic or inelastic for the word elastic. So in this case, they said it's an elastic collision. What is meant by elastic collision? The kinetic energy must be conserved. Before and after must be conserved. So which statement is correct? So what's the answer?
D. Wait. D.
Okay, elastic collision. Elastic collision, another feature is after collide, they won't stick together. They can't stick together. If they stick together, we say it is perfectly inelastic collision. It's an inelastic. Okay. If collide moves separately, it could be elastic, it could be inelastic. But 99.9% is inelastic. Okay. So in this case, can it be A as the answer? No way, because it's an elastic collision. Elastic collision, the body never stick together. Okay. Can it be B as the answer? Anyone? Is it B is the answer?
Energy after impact. Why is it squared? Wait.
Okay, sorry. Is it B is the answer? The total kinetic energy after impact is mv squared. What is the kinetic energy of the first body before collision?
MV.
What is the kinetic energy formula? Half mv squared, right?
Oh, okay, yeah.
So first body, what is the kinetic energy before collision? Half mv squared. What is the second body kinetic energy before collision? Another half mv squared. What is the total kinetic energy of the body before collision? Half mv squared plus half mv squared. Total kinetic energy is how much? mv squared. So total kinetic energy before collision is mv squared. So after collision also must be mv squared, right? Kinetic energy, if the object moves to the left, do you take the kinetic energy is negative? Like momentum. Momentum move to the left, you take momentum as negative. Kinetic energy, if it moves to the left, do you take it as negative?
No.
No. Why?
Square.
Oh, is it squared? Okay, better answer. Why? Why move to the left? You never take kinetic energy as negative.
Scalar quantity.
Very good. It's a scalar quantity, so no need direction doesn't matter. So total is mv squared before, so after also mv squared. So B is the correct answer. The total kinetic energy after impact is mv squared. Kinetic energy before is mv squared, after also mv squared. Okay. C is wrong. Can you give me the correct answer? Anyone? The total kinetic energy before impact is 0. Is it 0? It's mv squared, right? It's still moving, right? Both of them moving. So it's mv squared. The correct answer for C is the total kinetic energy before is mv squared. Can anyone give me the answer for the D? The total momentum before impact is 2 mv. It's a wrong statement. Correct answer is what? The total momentum before impact is. What is the total impact before impact? Total momentum before impact for this system. mv to the right, mv to the left. So total momentum. So total momentum is 0, right?
0, yes.
0 as a total momentum. So the D statement is wrong. It's supposed to be the total momentum before impact should be 0. Okay. The correct answer is B. So B is the correct answer. Okay, good. Okay. 11. Question 11, same here. Page 1. Okay, 1 minute for you. This is a little calculation. Need calculation. So I give you 2 minutes for you. Get me the answer. Use conservation of momentum to calculate the answer. So what is the answer? Boy, B. Is it B? Yes, good. B. I think this is a little straightforward now. B is an explosion. Okay, a body initial rest explode into two masses, M1, M2, then moves apart with V1 and V2 respectively. What is the ratio of V1 over V2? Okay, so of course, if you take the original mass, then they split crack into M1 and M2. M1 moves here with V1, M2 moves the other side with V2. So initially was in rest, at the beginning was in rest. So based on conservation of momentum, initial momentum should be equals to total momentum after, okay, final momentum, okay. So initial momentum is 0 because nothing moving. So M1, V1 have to be negative because look at the diagram, because V1 is moving to the left, so V1 will be negative plus M2, V2. So this is the formula. So the question is asking for V1 over V2, right? They're asking for V1 over V2. So from here, you rearrange V1 over V2. You'll get M2 over M1. You get M2 over M1. This answer. So you get B's answer. Okay, so initial momentum is 0. So final is negative. Okay. Okay. So answer is B. Just use conservation of momentum. Okay, this one. Prof, give me the answer. A, so 4. You got 4? So total momentum before is equals to total momentum after. So total momentum before, momentum of 2 kg is positive because moving to the right. Momentum to the 4 also positive. So M1 U1 plus M2 U2, total momentum, you add them. Okay. So 2 times 8 plus 4 times 2, get the total momentum equals to 6 times V. So it's because they stick and move together. Okay. So all of you got 4. So the total minus divide by 6, you get 4. All of you got 4. This type of collision, is it elastic or inelastic? This is perfectly inelastic collision. Because stick together and move together is perfectly inelastic collision. Okay. Okay, last question before we continue. Number 9. Okay, so what's the answer? So which of the following statement is principle of conservation of momentum? What principle of conservation of momentum say? For a closed system or for an isolated system, the total momentum must be conserved. So which is the answer? A, just momentum is a product of mass times velocity. Is that the principle of conservation momentum say? Momentum is mass times velocity? No one. You said about total momentum before and after is same. So A is outline. It's nothing to do with principle of conservation momentum. B, in an elastic collision, momentum is conserved. Momentum is conserved. Is it only elastic collision? Momentum is conserved for any type of collision. Is it elastic or inelastic or explosion? Momentum is conserved. So B also never explained by principle of conservation momentum. Statement B is correct, but never explaining the principle. C is the answer, of course. The momentum of an isolated system is constant. the total, to be more better, they're supposed to put the total momentum. The total momentum for an isolated system is conserved or constant. C is the best answer. I think they should say the total momentum. D is what? Anyone? D, is it anything involving any type of principle or law? What law is that? D.
D.
D, what law is that?
Newton's second law.
Very good. Newton's second law. The force is acting is proportional to the rate of changes of momentum. Yes, Newton's second law. Nothing to do with principle of conservation of momentum. Of course, the principle of conservation of momentum is formed from which law? Newton's third law and second law. We got the principle of conservation. Okay, class. So another 15 minutes, then we stop. Okay. Do you have class at 10 o'clock today?
Yes.
You have class, another class, is it?
Yes.
You have another class. Okay. So I want to give you homework, just one homework. Okay. So in this diagram, for only for elastic collision, can you prove that for a perfect elastic collision, the relative speed of approach is equals to relative speed of separation? What is meant by relative speed of approach equals to relative speed of separation? Okay, the meaning is, I go to the straight go to the straight go to what I want you to prove is for elastic, only for elastic collision, only for elastic collision. Okay, momentum is what? M1 U1 by assuming all the body, M1, this is U1, okay, so all moving to the right, M2 U2, okay, and after collide M1 and V1 all moving to the right, okay, V1 and M2, okay, all moving to the right, okay. By assuming this diagram all moving to the right, M1 U1 plus M2 U2 is equals to, okay, what? M1 V1 plus M2 V2, okay, right? All moving to the right. Okay, the first equation based on kinetic energy, because kinetic energy also conserve. Elastic means kinetic energy conserve. Total kinetic energy before must be same as after. What's the formula going to look like? Anyone? Half M1 U1 squared must be equals to half what? M2 U2 squared should be equals to half M1 U1 squared plus half M2 U2 squared. Okay, this is the second. Okay. By using these two formulas, okay, for elastic collision, kind of like 3 or 4 steps, 3 or 4 steps, 4 to 5 steps of calculation working, 4 steps, you will end up getting this formula. U1 minus U2 equals to V2 minus V1. You will end up getting this formula. Okay, this is called relative speed of approach. This relative speed of approach. Relative speed of approach. Okay, relative speed of separation. It's a relative speed. Relative speed. Relative speed means V2 minus V1 something. U1 minus U2 is relative speed of approach. Approach means when before colliding. Okay, V2 minus V1 is relative speed of separation. Separate, what is the relative speed? So the term you don't need to remember. Just what I want you to do as homework from these two. If your maths is good, you do simultaneous by using these two. You try to kill the mass. You have to kill the mass by using these two formulas. Okay, you end up getting U1 minus U2 equals to V2 minus V1. This equation is quite unique. Why is quite unique? No mass at all. Without mass, and this formula only can be used if it's a what type of collision? elastic collision. Inelastic, you can't use. Because why you can't use? Kinetic energy is not conserved. Okay, so this is your homework. How you can solve this, about 3 to 4 steps of working. Try to kill the mass and end up getting this formula. U1 minus U2 equals to V2 minus V1. Okay, if you can do this, your maths is good. Your maths. Are you taking further maths in your class?
Don't know.
So any of you taking further maths here? Okay, so those who are taking further maths, I think should be able to do this. Or those who are taking normal additional maths also, you can give a try. Okay, so this is your homework. U1 minus U2 equals to V2 minus V1. You need to kill the mass. Okay, factorize the mass out, kill the mass, make one side all M1. You see M1 on the left and M1 to the right. You bring all the M1 to the left, all the M2 to the right. You kill the mass, divide both equation, and you end up getting this one. Okay, give a try. Okay, so today's lesson, I'm going to stop here. Okay, I'm going to stop with telling you that for elastic collision, U1 minus U2 equals to V2 minus V1 only can be used if it's an elastic collision, and this equation is only correct by assuming all of the body are moving to the left. All of the body are moving to the right. Okay, if the U1 alone move to the left, the U1 alone become negative. Okay, so we will do that later, but first I want you to derive and get this formula. Okay, any question? Okay, so today's lesson is also quite a little taxing. Yeah. So what you learned today? You learned about Fully. You learned about Fully, Newton's law. You learn about momentum, principle of conservation of momentum, which you learned before. You learn which is elastic, which is inelastic. Elastic collision very rare. What is meant by elastic collision? Kinetic energy is conserved. Okay. Only elastic collision they found is the air particle collision. If anything said to be elastic collision means should not have sound, should not have heat generated. Okay. So how principle of conservation of momentum is formed? Based on Newton's second law and third law, the derivation you have to know. Okay. And finally, something new, a new formation of formula without mass can be formed only for elastic collision. Okay, so this is what you learned today. Okay, so if you don't have question, I can stop here because 15 minutes for you, take a break then for the next class. Okay, so any question? No questions. My class today is a little taxing, I know, it's about 1.5 hours. Try to take a short break, then think about this question today, how to get this. Okay, so I stop here. Okay, so everyone, no problem joining the team. So tomorrow also we'll be joining the team. Okay, let's stop recording. Okay, see you then.